Welcome back to the Chromeworks studio in beautiful Ottawa, Canada. I'm Andrew Tomec, your technology teacher, and I'm here today with a really cool new game I want to show you. So this is a project that Jeffrey's been working up for me. It's still a bit of a work in progress. What I wanted to do was a massive, epic RPG game that had all sorts of bits and pieces in it. We've had a lot of requests for RPGs, so Jeffrey and I put our heads together and came up with a concept for a samurai-themed RPG game that we think is going to be just spectacular. It's a huge project though, so we're going to split it up into a whole bunch of different parts to make it a little more bite-sized for you guys. So this week we're releasing two parts. I'm going to release part 1 today, and then tomorrow at 11 o'clock I will release part 2. And so part 1 is going to be setting up the player controller so that our character is moving around the screen properly, and so that he can be injured, so that he can die, so that he can attack, and just all the different animations that our player is going to go through. And we're going to learn a lot about how to animate stuff efficiently. Jeffrey created just a fantastic system here for controlling the animation that I think you're really going to like a lot. Part 2 that we're going to release tomorrow is we're going to bring our first enemy in. It's a skeleton, and we'll be able to start fighting him after part 2 is over. Next week we'll be back with a new system that lets us add maps to the screen so that we can start moving around from one map to another. And after that we'll be adding items like keys and locked doors and stuff like that. And we'll be wrapping the whole thing up in a few weeks, probably 3 or 4 weeks. We'll be wrapping up with the boss, who will be a really exciting project as well. So with that in mind, let's get coding. So with that in mind, let's get coding. So this is the starter file that you'd be loading up to get started with this project. It already has all the graphics that you need in it. We've got 2 characters in it, a skeleton and our player. The players who we're going to be coding first, let's have a look at his costumes here. So he has a bunch of costumes. We've downloaded these from an external source. I'll tell you all about it in a little bit. But so there's actually 39 different costumes here that show him in different stages. We've done a lot of work here to get the costume names uniform. We've got a bunch of idle animations, and you can see that they're all named player idle. Then we've got some run animations that are named player run. And we've got some attack animations. And in the end, we have some injury and death animations as well. And you can see our player kind of collapses and dies at the end. Poor fellow. Okay, so we also have a skeleton enemy here who has his own costume. So we've used the same naming conventions here. The name of these costumes is going to turn out to be very important in the way that we code this. But that'll all make a bit more sense to you in a little bit. So the backgrounds that we have loaded up here, not too fancy. We've just loaded a bunch of default Scratch costumes. The idea here is that you'll be able to use any background that you want to make your own RPG game off of this. And we're going to set up a system where you can define the area where players are allowed to walk. So in this case, your players, because we don't want them getting behind this tree, we're going to create a little rectangle here that your players will be able to move in, and that your monsters will stay in as well, and no one will be able to go past that. So every time you create a new level, you'll be able to define an area in which people are allowed to move, so that you can have some non-movable objects around the edge and walls and stuff like that. So it should be really cool. Okay, let's get started with the coding. So first of all, let's make sure we're coding the right thing. I'm on my backdrop now. Let's click on the player and start coding him. We're going to be doing the player pretty much nonstop till we're done here. We're going to start with a green flag right here. Let me magnify a bit for you guys. So let's nail down our character's starting position. We're just going to grab a go to XY block from the blue motion blocks. And in there, we're going to type in some numbers. So we're going to have our character start on the right-hand side of the screen. We'll give him an X of 240. And we're going to have him a little bit down the screen here like this. and that's going to be a y of minus 61. There we go. Now let's initialize a few variables. So let's go to our variables, our orange variables blocks here, and we'll go set. We've already got all our variables all set up. These are all the variables we're going to be using at least for the first part of the game. We might add some more in future weeks. And so we're going to set our animation name. Set animation name to 0. So we're just creating this variable called animation name, and that's going to tell you what animation we're in right now as we're playing the game. We're going to set our initial hit points as well. Set player health, and we'll give our player 3 hit points. We might have some healing potions or something in there later on to get your health back again. And most of the action inside the game is going to be inside a block here that's called a reset player. So we're going to broadcast that message. Let's go to our events block. We'll go broadcast. We have to type in a new message here. So let's just type in reset player. So generally speaking, the games we've been building lately don't start when the green flag is clicked. And that's because if you ever want to bring your player back to life again, or have him somehow shake himself off and reset himself back to an initial setting, you don't want to have that stuff happening under the green flag, because then you have to stop the game to restart it again by clicking the flag. So we put it inside an event, and then we can call it back again later and keep calling it through the course of the game without having to stop the game. So that's why you see this kind of structure here. So the code is going to stop here and continue in a new branch that's called reset player. First, we have to drag in one of these starter blocks here that's called when I receive. It's in the events blocks, and we're going to go reset player. So now when I get that message, the code is going to jump over there, back to here again, and this is going to control the main structure of the game. We're going to check and see inside this block whether a player's been wounded, whether a player is alive or dead, and we're going to tell him what animation to get into here. All those different sub-steps are going to be taken care of inside some custom blocks. So one of the ways we've made this project a little bit more better organized is we've created our own blocks to gang up different activities here, so that everything that has to do with our player getting wounded is inside one labeled block. Everything that has to do with him being dead goes into another block, etc. We've got another custom block here for our player moving, and another one for when our player attacks. And so the basic structure of this is going to go through these different blocks and check on a whole bunch of stuff. So let's go ahead. When I receive reset player, let's go create the custom blocks now. We'll worry about defining them later. So I'm going to go to the My Blocks, which is these sort of reddish blocks here. I'm going to click on the Make a Block button. So the first one we're looking for is called Player Wounded. So the order of this is actually very important. We're checking first to see if our player has been injured, because he's going to be doing a little animation that shows him going back when he's been hit. So even if he's been killed, we wanted to play the wounded graphic first before he falls down and dies, to show that he's been struck by something. So we're going to go player wounded here. As soon as we click there, that creates our new header here where we can put the details of how to do player wounded. And but we need to put a block here that actually calls it. So we've created this new block called player wounded. And so when the code gets here, it's going to jump over to the define block, do everything that it says, and then come back here and do the next step. The next step is a new block called Playerdead. I'm going to add that now. We're going to click on the Make a Block button, click Make a Block, and we're going to type in Playerdead. There we go. So that again will create a new custom block that will tell our player what to do when he dies. And that's going to be triggered off of this reset player code. So we just have to add a block here that says player dead. All right, so again, we'll worry about those details later. Okay, let's go ahead and program our third custom block. It's a little bit more complicated, and I'll explain how it works here. Our third block is going to be called set animation. And that is going to control which costume our character is wearing. So our character has a series of costumes that are idle animations, a series that are fight animations, etc. Each one of them has different numbers of costumes, And so we can't use the same one-size-fits-all code for all of them. So the way we get around that is by adding these inputs. And the inputs are a kind of parameter, basically information that the code is going to use in order to customize how it operates. So we're going to be able to create a custom block here that sets the animation, and we're going to be able to tell it, set the animation for a fight cycle, set the animation for dying, set the animation for being wounded. We can use the same block of code to do all of these things. Normally, if we coded it the old-fashioned way, we would have to have a different block of code to handle each of these operations. So we're going to have all of the animation stuff being handled from within this one block of code, but for it to work properly, we have to give it some extra information, and that's what these parameters are about. So the first parameter we need is called name, and that's where we're going to input the actual name of the costume that we want our character to be wearing. So in the case of idle animations, which is the first thing our guy's going to wear, we're going to type idle under the name, and it's going to keep working like that. Every time we want to use a different animation, we can drag in this set animation block and tell it which costume to wear. We need a little bit more information though. The second piece of information we have to customize is the frame rate, basically how fast our animation is going to play, because different animations will play at different speeds. So that parameter is called wait time. And so we're going to enter a number in there when we use this block that will tell us how fast the animation should run. The third custom block we need is just going to determine whether our animation is looping or not. So I'll call it looping. And the idea is that some animations, like us dying, we're only going to want to do once, whereas an idle animation where we're kind of going to be breathing heavily, like this, kind of bobbing up and down, that one is one that we do want to carry on looping. So depending on what that number is, whether it's 1 or 0, we're going to determine whether the animation plays once or keeps going. Okay, we can click OK now, and you can see that we have our new block defined here, and it has all our parameters set up in it. So this is where we're going to define how it works, but then when we actually use the block, by pulling out this here, we've got blank spaces where we can enter that information. So we're going to put the name of the animation here. So right now we are actually concerned with our idle animation, because when we reset our player, we want him back to the idle state again here. So let's go ahead, and I've lost my little block of code here. Let me just see if I can find it again. Here it is. So the name of that costume we want our character to be in is called player_idle. Now the spelling is actually really, really important here, because it's going to be looking for this string of text inside the costume names here. You can see we have a costume called player_idle. So if you don't type these in correctly, this code will not work. Okay, so our player idle animation, our delay in between frames is going to be 0.07. So basically 7/100ths of a second is how quickly each frame will pass. And then we do want this to loop, so we're just going to put a 1 here to tell our code that our animation is going to be looping. Okay, so once we've initialized our character and got it to determine whether it's wounded and whether it's dead and what costume it's wearing, now we can have it run through its movement and attack animation. These are things that I have to keep checking for constantly, so we're going to put it inside a loop. These things are just for initializing our character, and then it can carry on running from there. But we actually have to keep moving throughout the whole game, or checking to see if we're moving. So we're going to add that inside a forever loop. Let's go ahead to our orange control blocks, grab a forever loop here. And inside there, we're going to add our move player block. Again, it's a custom block. So let's go ahead and make another custom block. We're just getting stuff set up, and then we can start with the actual coding. So we're just going to call this one move player. It doesn't need any parameters, so we'll click OK. Now let's take our new define block and move it down to the bottom until we need it later. And we can actually add the the move player object in here. Okay, now we also need to determine if we're attacking in here, so we can play an attack animation. So we'll add an if statement here. So we're going to be moving based on our keyboard inputs, and that's going to be controlled here. Then it's going to jump back in again and check and see whether our space bar is pressed, because then it will know to get into an attack animation. So let's add an if statement here. if inside the forever loop, if we want to know if our space key is pressed, so we're going to go to our sensing blocks, where we can find this block here that says key space pressed. Let's go ahead and drag that into the little hole here. You can see the corners are the same shape, so we can drop that in there. If key space is pressed, then we're going to use an attack here. And again, we've compartmentalized all the attack stuff into a new block that's called player attack. Okay. And we'll do the same thing we did before here. We're going to drag the define block down here until we need it later. And then inside here, we're going to add the block that says player attack. So we're going to keep moving through this cycle as the game continues, checking to see if we have to move, checking to see if we've attacked. We're not wounded or dead, and so that's all stuff that will come up later again. We just needed to get it set up here. Okay, so that's the basic structure of the game. There's of the attack cycle anyway, or of the moving and attacking, which is most of what you're going to be doing in this game. We need one more set of blocks here under this reset player object, and that is going to determine how it's going to basically run how our animations are working. It's going to check and see whether, so in the case of idle, let's go back to our idle animation again. You can see how many idle animations do we have here. We've got 9 of them here, right? So we need to have our code basically checking to see whether we've got to the 9th animation and then sending it back to the beginning again. And that's what's going to keep happening over and over again. We can't have it inside this code, so we're going to create a new when I receive reset player here. Let's go ahead and do that. We'll go to our events block, when I receive reset player. And so these two things are going to happen in parallel, and that will make sure that the one event doesn't have to wait for the other one before it starts. These two things can both run simultaneously. All right, so we're going to be changing animations forever, and this block controls our animations. So we're going to have to put a forever in here, so that we're going to be doing different costumes, but we're always going to be going from one costume to another, and our character's not going to stop. Okay, inside there, the first thing we want to do is have our character wait for the length of time. That's the duration between frames. So this number that we put in here, 0.07, we're going to have it reflected in here, so that the program waits to see how long it will be before it has to change frames, and then it'll move on to actually change the frame of animation. So let's go ahead and we'll add a wait 1 second block. Now, under ordinary circumstances, we could put this wait time block from inside here and just drag it into here and have it wait that amount of time. We're not doing that this time because we actually need 2 different blocks of code to determine this. This again has to do with timing and not wanting to step all over ourselves here. This block of code is going to change costumes. All it's going to do is constantly be flipping through costumes to make our character look like he's alive. But we need a different set of blocks that's going to control which costume that it is that he's wearing. And the reason for that is because we have a wait time here, our code is going to fall behind if inside here we're also evaluating whether which costume to wear. We're going to end up not switching costumes until that wait time is over. So everything's going to be laggy and weird if we do that. So anytime we want to keep stuff moving simultaneously inside Scratch or any coding language, we need to have parallel processes running again. So we actually have 3 things running at once. It's running through this loop. It's running through this loop. So this loop here is determining whether we're moving and attacking. This loop determining which costume we're going to wear. And down below, we're going to be doing another loop later. Oh, sorry, this one is determining which costume we're going to wear next. So which idle animation costume are we going through? 1, 2, 3, 4, all the way up to 9, right? And the one down below is going to determine, am I wearing an idle costume or a shoot costume, or which kind of costume am I wearing? So all 3 of these are going to be working together to bring our character to life. So I can't use that animation name parameter or the wait time parameter. So later on, I'm going to be converting that into a proper variable. and that variable is called animation wait time. So let's go ahead. I've already created that variable. It should be in our variables list here, animation wait time. There it is. So let's tell it to wait that amount of time. And what we're going to do when we code our other block here is we're going to say set wait time, or set animation wait time to wait time. And so it'll always be exactly the number that we've entered here, but then when we change our animation, it'll change to a different number. Okay, hope that makes sense to you. So right after that, we're going to change to next costume. Once we've figured out how much delay to do, we can go ahead and change to the next costume in our list here. Now we need to check and see whether we're still wearing the right costume. We're going to be going around and around this loop, and eventually we'll run out of idle animations. We'll end up on a costume with a different name. We'll end up at player run here. The code needs to know that we've arrived at player run so they can go back to player idle 1 and start playing the animation again. So we're going to add an if-else statement, an if statement with an if-else statement inside it. It's a little bit confusing. So let's start with the if statement. We'll take an ordinary if statement and we'll pop it into right here. And what we're going to be checking to see is we want to check and see, am I no longer wearing the proper costume? If I'm not, then we're going to do what's inside it, which will bring us back to the first animation again. So the first thing I want to check here is if not. Let's go grab a not sign from our operators here. Not, there we go. So if I'm not wearing the costume name, so I need to basically say my costume name contains the animation name. So let's go ahead and grab a block that says contains here. So this is one of these text parsing blocks that we've used in a few of our projects. What this basically does is it looks inside this string. In this case, the example says apple. It checks inside this word to see if the letter A is there. So we're going to be checking to see if our costume name contains the word idle, basically, right? And if it does, then we're going to keep running the animation, ignore within this if statement, and just go to the next costume. But if it doesn't, that means we have to go back to the original animation again. So let's pop this contains block inside the not, because we want to know if it doesn't contain that. Now, we don't want apple here. We want it to say costume name. So let's go to our looks blocks. Towards the very bottom is this little block here that says costume number. We can change that to say costume name. We'll pop it in the hole. Change it to name. If costume name doesn't contain animation name, which is the variable that controls which, here we go, animation name, it's in my variable list here. So if it doesn't contain the name of our variable, then we have to go back to the beginning of the list. Okay, we need an if-else statement in here. So once we've gone through that first step of the filtering process here, we still need to check one more thing, which is this a looping animation or a one-time animation? So if it's looping, we'll know to switch back to the first costume and then go back to the beginning of the list. But if it's not looping, we'll need to tell it that the animation is over so that we can stop playing and go back to either an idle animation or just stop the game if we're dead. All right, so we're going to check here and see whether it's a looping animation. So we'll go if animation looping is equal to 1. So let's grab an equal to sign. And we'll drag that variable called animation looping. Let's go find it inside our variables list here. If animation looping is equal to 1, which means we are looping, then we need to send it back to the first costume. So we're going to switch costumes here. Looks, switch costume to, and we want it to switch back to the animation name, which is the first idle costume. The other ones all have numbers attached to it, but this one's actually called animation name. We can look at it up here. Player idle. It's actually called player_idle, and all the other ones have numbers attached to them. So this is the only one that's actually just called player idle, and it'll go back to that first animation. And the same applies to our other animations. They're all named very carefully. So our fight animation starts with the word fight. Let me show you. So we've got our player run animation here, for example, that starts with the word player run, and then we just add the numbers afterward. It'll cycle through all of those and then go back to the beginning again. Okay, so we switch costume to animation name. Let's go ahead and find that variable in here, and then we'll bring it back to the first frame of that animation. And now the else statement is if the animation is not looping, we need to do something else. So we're going to switch back to the last costume that we were wearing before we ran out of animations. So let's go ahead and go switch costume to looks, switch costume to, but we're going to put a variable in there. We're not going to put a proper name here. Now we wanted to go back to the costume I was wearing just a second ago. So we're going to subtract 1 from the costume number, and that will bring us back to that spot again. Let's go to our operators. We'll grab a subtract sign here and pop it in there. And I'm going to say costume number minus 1. So let's go ahead and grab costume number, which is under our looks blocks here. Costume number, and we don't have to change this one around. So switch back to the previous costume. And then we're going to set that variable called animation ended, set animation ended to 1. So that will tell the code elsewhere that that animation is ended, and we'll know what to do then. And then we need to just basically have this, this script sit in a holding pattern until the animation ended goes back to 0, which means we've reset to a new animation again. So let's grab a wait until block. We can find those under the under control block. Sorry, wait until. So our animation is going to freeze here inside the else statement and wait until animation ended is equal to 0. So let's go grab an equal sign, pop it in there. We're going to type a 0. And our variable is going to say animation ended is equal to 0. Okay, so now it's going to sit here in a holding pattern waiting for that variable to flip back to 1 again. That's all being controlled over by the define set animation end block. All right, so we haven't coded the part of the program that determines which costume we're wearing, but we did code the part that says switch through the different animations for the costume that you happen to be wearing. So we were actually at a point where we can test our program and see something happening. I thought you guys would want to do that. So I've gone ahead and set something up that basically fills in what these variables are going to be. That part is all going to be handled a little later in the code. But for now, just to simulate it, I've created some set variables here. We're setting our animation name to player idle, setting our wait time. So that's all the information that was contained in here. But we're just going to, because it's not being processed yet, we're just going to artificially do it. Let's click the green flag and we can watch the animation happening here. You can see that we'll move it back to the middle so you can see that he's switching back and forth between his different animations here. Beautiful. So we can use this to simulate other animations as well. Now I don't want to restart the program here, so I'm just going to cut this loose and I'm going to change this variable here to call it player_run with a capital R. And let's just run this block of code again just by clicking on it so that we don't have to drag our character back again. Now he's in his run animation, you can see. Looking really cool. These are really beautiful animation blocks, by the way. I'll tell you a little later about who created them. All right, and let's try one more animation. Let's go grab the fighting animation, which is player_attack. We'll change the animation to that. Player_attack with a capital A, a CK. Let's click on that. And now my character is swinging his sword around. Really cool. Ah, yeah! Beautiful. I actually really like that a lot. Okay, and so you can see how this is going to work. It doesn't determine which costume you're wearing, though, as I said, and that's the part that we're going to do here in a second. I'll just show you as well, by the way, that this animation, this looping variable here, let's just change some of these parameters around to show you what's happening. So if I wanted the attack to happen faster, I could change this wait time to 0.01, and you'll see that he's swinging his sword a lot faster. Yeah, he's going super fast now. And if we don't want the animation to loop, we can add a 0 here. And again, let's click on it once. And you can see he swings the sword once. And then he's done. And he won't do it again. Even if I invoke this animation, we've got to switch the looping back to 1 again. Oh, I think our code is stopped here. I probably hit stop there without realizing it. Anyway, we don't need this code. I'm just going to trash it right now because we're going to do all of these functions inside another little block of code, which we're going to do right now. So let's stop our file. And we're going to go down to the define set animation block, and we'll fill that in now. And that's where the rubber really hits the road with this animation. So let's go ahead and fill in the blocks for that. Let me find it in my reference code here first. So here it is, set animation. So we're just going to tell it what those variables are. Player idle, delay time, and looping. That's one of the things that we're going to do here. So let's go ahead and set the variable called animation wait time. And we've got to get it to match the actual wait time that's in here. So we can go ahead and drag this block called wait time right into the loop there. So it's going to use that information and feed it into this variable here. There we go. Now we need an if statement in here. And we're going to be checking again here to see whether our animation is over or not here. So we're going to be checking to see if the name of our animation is not the original name. So if the name, which is right here, isn't equal to the name of the animation, then we're going to go to the next animation basically. So when I say equal to the name, let's get it typed in here, and I'll explain it in a second here. So let's go grab a not sign under our operators. And we'll grab an equal sign. So if we're not equal to, and what is it we're looking for? So we'll drag the name into here, and on the right hand side we'll drag the variable that says animation name. You can see our animation name right now is player attack, and that was the last piece of information we gave to that. So what we're saying here is if the name isn't exactly equal to player attack, if it's player attack 1 or player attack 2, we'll know that we're not at the beginning of our animation, and we can switch to the next one. If it is, though, we're going to want to switch back to the first animation, and that's going to be controlled over here. So we're just going to tell it to flip to the first animation in that particular cycle for idle or fighting or whatever it is that we're doing here. So inside here we want to set animation ended. Set the variable called animation ended. We're going to set it to 0 to say our animation is definitely running right now. We're going to set our animation name to name. So that's just going to make it match what we set in our parameters back over here. There we go. So the animation name variable will match that now. Now let's go set animation looping. So whether it's looping or not, we'll set that to the to this looping variable here. So that'll change it into a 1 or a 0 that we can use later on to determine whether our animation's running or not, whether it should continue running after it finishes the first time. And then let's just switch our costume here. So let's go looks, switch costume. Right over here, switch costume to the costume that's in our animation name. So let's go ahead and grab that from our variables list. We'll find the one called animation name and drop it in there. So the last step he's going to do is he's going to start wearing the costume. Once all these other variables are selected, he's going to start wearing the costume the way that we want him to. So these two sets of blocks here working in unison. I know this is a bit confusing, guys. So this one is the one that's going next costume, next costume, next costume, and switching it back when it ends the cycle of that particular costume. When the idle gets to number 9, it'll switch it back to the beginning. This one is determining which costume is it wearing. Am I wearing fight? Am I wearing idle? What am I wearing? And you can see now that it all works. When I click the green flag, I go back to the right-hand side here, and it's reading the blocks properly. It's in an idle animation. I can even pull a custom block out here that says set animation, and I can change it to whatever information I want. So let's go ahead and change the information in here to a different state. So we will set the name here to player underscore attack. To get our attack animation going, we will set our wait time here to, let's just call it 0.04 to make it nice and fast. And then we will set the looping to 0, so we only does it once. Okay, let's go ahead, click the green flag. He's in his idle animation right now, the way we told him to, but as soon as he gets this command, you can see he'll go into a sword swoop. He'll attack once, and then he'll be done. I'm going to hit stop and start again. This time, we're going to change the looping to 1. And let's try that a different time. We'll click on it. And now you can see he's continuing to attack because his looping animation is set to 1. So I hope you're starting to see how you can use these custom blocks with parameters in them to take the place of a whole bunch of code that you would otherwise have had to customize for each individual thing, right? So now all through our code, every time we want our character to set it to change his animation, we can just add one of these custom blocks, fill in what we want our animation to look like, and we don't need a whole bunch of new code to do that. It's all handled very efficiently. So hats off to Jeffrey, my master coder son, who's just excellent at putting this stuff together. And he's found a really simple, elegant way to control this character. You're going to be able to use this later on in your own games, right? Any kind of a combat game where you want to have a character going from one animation to the next, you could theoretically use this kind of a system to set it up just by dragging this stuff into your knapsack, your backpack, and redeploying it. And maybe when we're done all of this, I will show you guys how I would go about using that in a different project. Okay, so we're making good progress. We haven't done a lot of coding so far because there's been some complex stuff that I had to explain to you, but we're getting into something a little bit more straightforward now, which is movement. So we're going to blast through quite a bit of this, I think. All right, let's get back to our code. All right, so I'm working on the define move player block, which is going to control all of our movement for our character. So let's go ahead. First, we have to set a variable. We're going to set a variable called moved this frame. And we're going to set it to 0, which means we haven't moved this frame. And this will let our game know whether it should switch into or out of an idle animation, right? Whenever you're not moving, it's going to flip back to an idle animation. But it has to know not to be waiting for a keyboard input and just to go back to the ordinary idle one when we're not moving. So we use that variable to help keep track of that, whether we've actually moved this frame. Let's grab some if statements here. Now this doesn't, normally an if statement has to go inside a forever, but this define move is all already inside a forever loop. It's just a little hidden from us. So that's why we don't need to create a loop here under define movement. Let's go ahead and grab an if statement. And we're going to say, I'm going to add double keyboard inputs here. So we're going to do WASD and arrow keys, which means we need to put an OR statement in here. I'm just going to go OR, and let's grab our keyboard inputs from the sensing command. I'll grab the one that says key space here, and we'll tell it if key D is pressed, or I'm going to duplicate just to save some time here, or right arrow key is pressed. Right up here. Then what are we going to do? We're going to change our X coordinate by 4. Change X by 4. So that's going to move us 4 to the right when we press the right arrow key. We want to point our character in the proper direction. So let's tell him to point to the right here. Well, to a direction of 90. And that will get our character facing in the proper direction. I'm pretty sure that we've locked our direction here. Yeah, so our directions inside here are locked, which means that our guy can't flip upside down when we tell him to move to the left. And so we just left it there by default. If you wanted to switch back and forth, you needed your character to be upside down for some reason, you could always unclick it here and then use code to control whether it's allowed to flip or not. That's rotation style is what it's called. But because our guy is always going to be upright, we can just lock it here and not worry about it again for the rest of our code. Okay, so after we point in direction and change our X, we're just going to set that variable to move this frame. The one that we set up here, we're going to tell it, oh yeah, we did move. So we'll set that to 1, and then we'll keep track of whether we moved or not. Okay, let's go ahead. So we need to do the other 3 keyboard inputs. We've done left, we need to do right, up, and down. Rather than reinventing the wheel here, I'm going to duplicate this by holding my cursor over the if statement, right clicking and selecting duplicate, and then just right underneath it here we'll put the other one. So this one is supposed to say A when I press the A key, or the left arrow key. Then we're going to change our X by -4. And we're going to change our point in direction left, which is -90. We still need to change this, move this frame to 1. Okay, let's duplicate this one more time and we'll do up next. So if key up arrow is pressed or key W, I did that in a different order, but it doesn't really matter. If I hit W here, then we need to change our Y, not our X. So let's go ahead and we'll get rid of that. We'll put a change Y block in from our blue motion blocks. Change Y by 4. And we can drag these blocks back in here. And we'll change this to up. Good. All right, and the last one should be a little easier. So we'll go duplicate. And when I press down arrow or the letter S, we'll change our Y by -4. And we'll point in the downward direction, which is 180. And everything else is good. Okay, so our character should be moving around now. He's not going to be wearing the right costume yet, but let's just test it out here. So I'll move to the left, and you can see that his idle animation is moving around. So he's moving properly, but he's not switching his costume around. And we can fix that right away. So let me stop, and we'll keep going now. So now here's what we're going to be checking to see if we flip that variable, move this frame. So let's go if under control, if, and we'll grab an equal sign here under operators, equal, there we go, if, and we'll find the bubble here that says move this frame. So if move this frame is equal to 1, which means we have moved, then we're going to set animation. And here we're going to use our custom block. So let's go set animation to player run _run. Make sure you're spelling this properly. And then the delay time is 0.07 and the looping is yes. Oh, and this is an if-else statement. I've made the classic error of mistaking if for an if-else statement. Let's grab an if-else statement here. I'm just going to put these contents into there. There we go. So now we have an alternative thing to do. If we haven't moved this frame, we're going to switch back to our idle animation. So let's just duplicate this and we'll change the name here to player idle. So now, depending on whether we're moving or not, our costume knows to wear one of two, or sorry, our player knows to wear one of 2 costumes. Let's maximize here and we'll have a look. So now when I move, you can see that he switches to a movement costume. And as soon as I stop moving, it goes back to his idle again and starts idling up and down. Looking really nice already. Can't attack anything yet because we're not quite ready to go. All right, let's keep coding. All right, so here's the next thing we need to do is limit our movement on the map. And that's because, let me max this out one more time. We've got a tree here at the top of the map and it really ruins the realism if our guy is going in front of the tree when it looks like he should be going behind it. Now I showed you guys last week how to code this so that he goes behind the tree, and we would have to create a separate sprite for the tree. I'm trying to keep this really simple this week though, and I don't want to mess up our code. So instead of doing that, we're going to define an area at the bottom here where our character and our enemies are allowed to move. And depending on what map that we're on, the size of that box will change. So we're going to kind of chain up our character so that he's not allowed to move out except outside of that box just by entering some numbers here. So let's go ahead and start coding that. So we need another if statement. We'll say if our X position is greater than, so let's grab a greater than sign here. So our X position, where we are horizontally, we can find that under our blue blocks here towards the bottom. There's X position right here. So if our X position is greater than. Now we've got some variables here that control map limit, and we're going to be able to set those up. Next week we're going to set up our map so that no matter what background we put in here, it'll always have limits set up for itself that you can set up when you create the map, and that'll be parameters that we set up. For now, we're going to just create something temporary that works for today. So if x position is greater than a variable called map limit right, then we're going to set x back to a number. We're going to bounce backwards. So we'll go to motion. We'll set x to map limit right again. So if we try to go past that number, it'll just bring us to that number, our right hand limit on the screen here. Okay, we're going to be doing some similar stuff here and making copies of it. So let's go ahead and copy the if statement. We're going to say if x position is less than. So let's grab a less than sign from our math operators. So one pointing to the left. And we'll say if x position is less than map, not map right limit, but map left limit. So let's find the block that says map limit left. Then we're going to set our x to match map limit left. There we go. Now let's duplicate again. Now we're working on the y position. All right, so in this spot here, we're going to say if a y position is less than map limit down. Let's go ahead and find those blocks. Y position is under motion. So if y position is less than the variable called a map limit down, we can actually change that variable without going back to our variable list here, just by right-clicking on it, and we can select it from the pull-down list here. This is not something I've shown you before, but it's actually a nice little feature to save some time. We want to be fast and efficient in our coding. So if y position is less than map limit down, let's set our y. Let's go ahead and do that. We'll set our y coordinate, which is again a motion block, to, let's duplicate this, map limit down. There we go. And lastly, we need one for up. So let me duplicate again, duplicate. If y position is less than, let's right click here, say map limit up, set y to map limit up. Okay, now you might have noticed that we haven't initialized these variables map limit. They're going to be changed depending on which map that we're on at any given moment, right? And so we're going to deal with that next week. I've temporarily set something up here with the initial variables though, and so this is what you're going to have to enter just for this time so we can test our code out. So the numbers are for map limit left, -226, for map limit right, +226. For map limit up, we're going up to -58, which is just under this tree. And for map limit down, we're going to go to -140, which is right towards the bottom of the screen here. And so once you've entered those numbers, we can test our game. Let's maximize our screen, stop and restart our program again, and try moving around. So I'm moving around, and I can move up but not down, which means that I've probably flipped something somewhere here in my settings. Let's go have another look at my code. Oh, you see I have a less than sign here instead of a greater than sign there. That'll mess you up every time. So if so for up, we want to make sure it's not going greater than a certain number. I can't actually change it. I thought maybe I could right click it to change it. So we're going to have to go find a greater than sign here, which is the arrow pointing to the right. And let's sub in that information. These kind of things come up all the time when you're coding and just forget to do something. And that's why we play test things. We're always making sure that we've got the right settings here. When we make a mistake, we fix it right away rather than letting errors pile up. So there we go. We're moving left, right. And when I try to go up off the screen, I'm frozen. So I can't go behind that tree. If I try to go off the bottom of the screen, that's as low as I can get. When I try to go right, I hit that limit. And when I try to go left, I hit the limit again. Beautiful. Okay, it's looking really great here. Okay, so we're almost done with the player movement. The one little visual effect we want to do here to make this extra cool is when our character moves to the foreground, we want him to grow and we want him to shrink when he moves back. And that'll create a little bit more of a 3D effect here. So we just got to do a little bit of tricky math to do that. Let me show you. So right underneath our Y position map limit here, we're going to add a set size block, which is under looks, set. We're going to grab the one that says set color here, and we'll change it. Oh, that's not the right one. Set size is a different one. Where is set size? There it is, set size to 100%. We're going to grab that and pop it underneath here. Now we need to do some math here, basically. So the higher up we get onto the screen, the smaller we want a character to be. But we've got a problem here because we've got some negative numbers going on here, right? So our numbers could go all the way down to minus 180. So to fix that, we're going to add some numbers to our current Y position and then multiply it by a number, which will finally yield us with a number that will be a percentage, the amount of size we want it to be. So right now we're at 100%. Let me just show you what that looks like. So that is the character at 100% here, but we can get much bigger than that, right? So if I go 200% here, that's him at the biggest size. I don't think we're going to go much less than 100% here. So instead of punching a number in here, let's put some math in here. So we need a plus sign. Let's go grab a plus sign from our operators. And we're going to grab a multiplication sign, which I know kids your age probably have some trouble with, where it's the one that's shaped a little bit like a star here. We don't use an X for multiplication when we get to high school, guys. All right. So set size to Y position. Let's go find our Y position block. So it's going to be a function of the Y division, meaning it's going to, the Y position. So we're starting with the Y position, then modifying it by multiplying it by something, and then adding something to it. So we're going to multiply it by 0.5. And we're going to add 110 to it afterwards. So these numbers seem kind of pulled out of my hat here, but you can see how they work. I'm just going to grab this set size here and pull it loose so I can test it a little bit. So you can see here when I click on this, hold it. Oh, it's minus 0.5. I have the wrong number here. Okay. So here's the size when he's at this Y position. And when I move him higher on the screen, way past the limits here, the limits are going to stop me here. Hey, let me stop my file here so I can show you the extremes of this. So when I move him back up here, you can see that he goes much smaller. So depending on how far I am up or down on the map, he will get bigger or smaller according to a certain number. But the max small and the max big are very tightly controlled by these numbers. We have to do some playing around to get these numbers set up exactly right. So in this case, we'll set size to what percentage when I'm at the front? We can actually pull it loose and click on it and see the result. So this is 170%. And when I move it way up to the top here, the number shrinks to 90%, which is a little bit smaller, right? So depending on where we are, we're going to gradually grow or shrink. We just had to play around with these numbers to do something that looked realistic. If you put different numbers into here, you'll see something much, much different. So if I type a -1 here, for example, and pop that in there, you can see that the size is much bigger at the beginning. And when you move it over here, it'll be much, much smaller. So that's too much of a difference. And that's why we had to play around with this and come up with a different multiplier. -0.5 gets us to the right place. So let me just work through the math here, guys, just so that you understand it. So let's set our Y position to 0, which is right in the middle of the screen here, right? So if my Y position is 0, 0 times -0.5 is 0 plus 110. So we end up at a Y position of 100, or a size of 110, right? If our Y position is down here, let's bring it down to -100. Then our size is going to be 160, right? You can see that over here in this frame here as well. You can see the size is 160. So, so yeah, that's how that math works. So we're taking that initial number, which is minus 100, we're multiplying it by a minus number, which will give us a positive number of positive 50, plus 110 is 160. Oh no, math again. Okay, let's try it at a y coordinate of positive 100 and see how these numbers work here. So we're way up here now. So if our y position 100 times minus 0.5 gets us to minus 50. So we go from 100 to minus 50 plus 110. So minus 50 plus 110. Oh, the math is too hard. It actually gets us to 60. And you'll see that when I click on the button here, our size shifts to 60. So we did a bunch of playing around here, and that just seemed like the natural size. Once we run it in the program, you'll see it working a lot better here. So let's click the green flag. And we'll move up, so move down. You can see we get bigger, and we move up, we shrink. And so it's just a subtle change, but enough to give the game more of a 3D kind of feel to it. Nice, eh? So we kind of faked our own 3D just by doing a little bit of math. And you guys said math wasn't important. I hope you're learning how wrong you all are. Okay, so we are done with the movement algorithm now. We just have a few other little blocks to deal with for our character, and that's the custom blocks that we need for attacking, being wounded, and dying. And let's set those all up really quickly. They're not too big. So let's start with player attack. I'm gonna have to go and find the block here, the custom blocks that I created way earlier today. They're way over here. I'm just gonna grab them and bring them over to the side here so we can start coding them. All right, let's start with player attack. And we will code that. Let me zoom in for you. Okay, so when we're attacking, we want to set our costume or animation. So let's go grab our new custom set animation block, and we'll change it to say player underscore attack. And I already showed you how that works. Our number here for the delay is going to be 0.06, and our loop is going to be 0 because we only want to attack the once. Now, we're going to wait just 0.1 second here before we start attacking. Just looks a little more natural. Then we're going to start a sound effect. We already have a sound effect in here called /1. And we've got a different one here for the sword backslashing the other direction. There we go. And so in true samurai style, our guy is not going to hack with the sword, but he's going to do an elegant whoosh, followed by a whoosh back in the other direction again. And that's the way that that works. So let's go back to our code here again. And we'll tell him to play that first sound, or start that first sound. Start sound /1. Then we're going to wait for this sound to finish. So we'll just do a wait effect here. We're going to go, to our control blocks. We'll wait 0.6 seconds. And then we'll start that other sound, /2. So let's go back to our sounds here. Start sound, /2. And we're just going to wait until that animation is over. We'll know our animation is over because that variable called animation ended is going to equal 1. So let's go grab a wait until. So we're locked into this animation now. We can't move or do anything else until we're done with our animation. And that's the way it usually is in these combat games. You have to stop in order to attack. So let's go, no, not wait, but wait until, which is a little bit further down here. Under our control blocks, wait until. Let's grab an equal sign from our operators. And we'll go animation ended, which is a variable right here. So we'll wait until animation ended is equal to 1. And when that happens, we'll exit out of the code and go back to our main block of code, which you might recall from over here. So after we're done with the player attack, when we hit the space key, then we're going to go back and continue moving again, basically until the next time we want to attack. Okay, we're going to go ahead and program player wounded now. Now this is a block of code. This in Playerdead, the code is actually running through this every time, so we don't want it to run automatically. We just want it to test here and see whether we actually have been wounded and whether we actually are dead before it actually does what it's supposed to do and runs us through that that animation for us being wounded or dying. So let's start with player wounded here. So we'll have to add an if statement in here that will control whether that will check and see whether we've been wounded or not. How do we know we've been wounded? Well, our player health is going to be less than 3, and that's how we'll know that we've been wounded. So let's go ahead and inside the if statement, we'll grab a less than sign here under our operators. Less than. So player health, which is down here in our variables, is less than 3, which means we have been wounded. Then we're going to set our animation to player injured. So let's use our new set animation block. We'll go player underscored injured, being very careful to add the capital letters where we need them. And then our timing here is going to be 0.08, a little bit slower, and 0 for the looping. We just want that to happen once if we've been wounded. So then we need to basically freeze on this animation until the animation is over. So we're going to play that entire jumping back animation, and then when that happens, we're going to release it and go back to our idle or attack or whichever animation we need. So let's go ahead and go grab a wait until block from our control blocks here, and let's wait until we need an equal sign. And we're going to say animation ended is equal to 1. So because this isn't looping, it's going to run through once and then flip that animation ended to 1. And it's going to wait here till that happens and then go back and restart the whole loop to get us moving again and attacking and doing all that other fun stuff. Okay, so let's test out this wounding graphic right now. In order to get this working, we have to change our health to less than 3. So we'll make our health 2 temporarily, and we're just going to call this message that's called reset player, and that will run it through the entire routine again, where it will read that our health has been changed and wound us basically. So we just have to click on this and we can actually see it happening. And I want to maximize the screen here, so which means I won't be able to click on these blocks. I'm just going to add a when A key pressed or something, or WASD. Let's go B, I guess, so because I haven't used that key already. So let's maximize my screen here, and as soon as I hit the letter B, you'll see that I get injured and I flip backwards a little bit. My character turns white a little bit, which is one of the actual animation states here. It's just to create a little bit of visual feedback that you've been hit. Your character turns white and then he jumps backward. Let's do that again. Boom, like that. So every time I do that, so that's what's going to happen every time I'm actually struck by something. And the bad guys are going to do the same thing when they're hit as well. All right, so we don't need this right now, but we're going to use it again when we die. We're going to set our player health to 0, and then we can simulate ourselves dying. So let's go ahead and do that right now. All right, so let's define our player dead now, which is right here. So again, we're gonna be checking to see if our player health is less than a certain number. We're actually going to use a lot of the code we already have here in the player wounded. So let's just do a duplicate of this. Let's go right click and duplicate. So we're going to say here under player dead, we're going to say if player health is less than 1, which means it's equal to 0, then we're going to set our animation to player underscore death with a capital D, which is the animation for that. It runs very quickly, so we're going to go 0.01, and it doesn't loop, so we're going to leave the looping at 0. Then we're still going to wait until animation ended is equal to 1, and then we're going to run through, so once we finish playing our animation, we're going to fade away slowly. So let's go back to our to our repeat loops here. We'll go to control. We just want to fade away slowly until we get down to nothing. So we're going to repeat 40 times. and we're going to change our ghost effect here, which is going to make us fade away. You guys remember the ghost effect is what makes you transparent. So I'm going to grab a block here from the purple looks block. So that's called change color effect. We'll hold the little options button down here and change that to say ghost, which affects transparency. And we're going to have it changed by 2.5 at a time. So you guys, of course, know that 2.5 times 40 is 100, which will get us totally transparent. Okay, and once we're finished running that script, we can just stop this script from running, which is basically going to stop us changing from different animations. So let's go under our control blocks, down at the bottom here where it says stop all. We'll change that to stop this script. Still inside the if statement here, stop this script. And that will stop us. So let's go ahead and simulate our death now. So I'm going to go max my screen out and hit the letter B, which will bring our hit points down to 0 and should stop the program here. So let's go ahead and we'll move back to the middle here. Then I'll hit the B button, and you'll notice that I get injured first because it's always evaluating whether you're injured first, and so will flop backwards, get injured, and then we'll die. Watch. Boom, and then he's dead. Let's try that one more time. So that's the beauty of the way that Jeffrey coded this. It's always checking to see if you're wounded before it kills you, and so we don't have to do an extra bit of code to be wounded before we die. It just automatically runs itself. Ooh, and there we go, and then we're gone. And then the game's basically over because we don't have lives in this. Well, I'm not quite sure how we're going to manage this. We're going to deal with that later, though. Okay, so that is it for player death, and I think we're basically done the player controller now. That's all the code we need to have to run our player. We're going to add some more at a later time, probably next week, when we start adding maps and stuff like that. But this is all the code you need for today's lesson. So that's the end of part 1, which is today's lesson on this. We've got our character moving around. So part 2 is we're going to drop tomorrow, Sunday at 11 o'clock. And then next week, we're going to drop part 3, which will get us into moving maps and stuff around. And we haven't finished developing the rest of it later, so I'm not quite sure how many parts this is going to end up being. It might end up being 7 or 8 parts, but I'm trying to cut it into bite-sized chunks that each deal with a different topic. So we've just finished part 1, which is our player controller, and it's even if you're not interested in following the rest of this code, I think this is a really useful little bit of script here that you can actually redeploy in all kinds of other video games. So the costume animation system we've used here is very, very useful for all kinds of other games. If you have anything that cycles through costumes when things happen, all you have to do to remix this is just grab all of this code and just find some new costumes. So find any character with any number of costumes in it and just label your costumes properly, right? So if there's a costume for running, just call the first one running, and then call the next one running 1, running 2, running 3, etc. You can have a different costume for everything that you do, and we can reuse all this code again. So it's a fantastic system that Jeffrey's created here that you can use for almost any game, not just for RPG games, but for arcade games and other stuff as well. So do have a look at this and see if you can find a way to use this again. In the meantime, I am going to log off for now, and I'll be back with part 2 Sunday at 11 o'clock. Thanks, guys.